There's a lot of stuff we're going to cover today, and it deals with a lot of writing. So we're going to go through graphing parabolas, and we're going to start with the standard form. This y equals ax squared plus bx plus c. That's called standard form. There are specific steps we're going to follow. I'm going to walk you through this, and we're going to practice going through it. First step, we're going to find the vertex, and it's going to be a point. It'll be an ordered pair, and we're going to actually find it by realizing the x-coordinate is the following formula. It's a formula. You might want to highlight this. X is equal to, or the x-coordinate of the vertex is equal to the opposite of b over 2a. So from standard form, the x-coordinate of the vertex is by taking the opposite of this coefficient and dividing it by twice the first coefficient. You may be questioning, well, why is it that formula? And we will learn why it's that formula later on. We're just going to start off with how you graph these. So let's talk about how to find the y-coordinate. If we use this formula for the x-coordinate, we're just going to plug it in to figure out what the y-coordinate is. So once we find the x-coordinate, we'll plug it in to find the value of the y-coordinate. That's our vertex. And we'll see what that is. A vertex is the turning point in a parabola. Determining which way the parabola opens. If that leading coefficient is bigger than 0, parabola will open up. If that leading coefficient is less than 0, parabola is going to open down. We're also going to find an axis of symmetry, and that axis of symmetry is going to run through that vertex. It's going to be the vertical line going through that vertex. We'll create a t-chart, so that's going to take a little bit remembering of what a t-chart is. We're going to create a t-chart, find another point, and graph it using the axis of symmetry. And then using the point that we find from this t-chart, we're going to map it using that axis of symmetry. First example is figuring out how to graph this equation. When we write this down below our equation, we can easily see, okay, what's our leading coefficient? What's our second coefficient? What's our constant term? Our vertex, the xy coordinate, in order to find x is that formula. I've got to figure out what the opposite of b is and divide it by 2a. So using that formula for our x-coordinate, we realize it's going to be -1. That's our x-coordinate. So our vertex is -1 comma something. We have to figure out that something by plugging it into the equation. Using the original equation, we're going to plug in -1 to figure out what our y-coordinate is. So we get 1 minus 2 plus 1. We're looking at 0. So going back up, our vertex is actually going to be -1, 0. Let's plot that point. And let's put a V by it. That was all just the first step. Second step was using that leading coefficient. What is in the place of A? If A is positive, our parabola is going to open up. If A is negative, that leading coefficient, our parabola is going to be going down. So you look at our leading coefficient was a +1, which is bigger than 0, so we're going to be opening up. Axis of symmetry is going to be whatever our x-coordinate was to our vertex. So we're going to draw an axis of symmetry through -1. It's a vertical line going through the axis. Now, this is just to help us map the parabola. Parabolas are always symmetric, and it's going to be symmetric across this line. That's why it's dashed. It's not supposed to be there, but we need it there to figure out, well, how to graph parabolas. We got to pick an x-coordinate that is not -1 because that's on our axis of symmetry. So you could pick 0. Pick an x-coordinate of 0 and plug it in. And it ends up being just a 1. So I get a point of 0, 1. I'm going to graph that point. fifth step is strictly using the graph. Fifth step is mapping this point on the other side of this axis of symmetry. Parabolas are always symmetrical through its axis of symmetry. So if this point is 1 away from that axis, or you could map it from the vertex, it's 1 up, 1 over. The point mapped on this side should be 1 up, 1 over on the other side. It's got to be extremely perfectly matched. We connect the 3 points and make sure that we're opening up. Let's actually write below it the standard form of an equation to help us out on how to graph. When we figure out our vertex, we're going to use the formula for the x-coordinate as opposite of b all over 2a. So you got to figure out, I pick out what's in my b position, what's in my a position, and I want the opposite of b in my formula. That's what this is saying, the opposite of your b coefficient. We're looking at an x-coordinate of -2. To find your y-coordinate, you plug it into the equation. So our vertex is going to have an x-coordinate of -2, like what we found before, y-coordinate of 3. We graph it. Second step is realizing where your axis of symmetry is. No! It's what's going on with A. What's going on with your A coefficient? If your A is positive, we're opening up. If your A is negative, we're opening down. We got to figure out our leading coefficient. If it's positive, it'll open up, but in this case, it's negative. It's less than 0. So we're going to open down. I'm going to draw a vertical line going through the x-coordinate -2. That is my axis of symmetry. Axis of symmetry is always a vertical line through your vertex. Or you could pick 0 for your x-coordinate. Either way, but you're going to go back up here and plug it in. I get a point of -1, +1. I plot the point. The fifth step is taking that point. Fifth step strictly deals with that, with the graph. If you're on this side of the axis of symmetry, notice how I'm 1 away from the axis of symmetry. So that means I should be 1 away on the other side. Or you could map it from the vertex. You could say, well, I'm down to right 1 over here. I'm going to be down to left 1 over here. Either way, it's going to be strictly symmetric across that line. I go back to number 2, and I should be opening down. So I'm going to connect these 3 points, making sure I'm open down. This is an example where we don't have an x term, so b in this case is going to be represented as a 0. When you're missing a term, it's going to be represented as a 0. So when I use that formula in my first step to find my vertex, I'm going to make sure the opposite of b, I'm using a 0. We get an x-coordinate of 0. I'm going to plug that in to figure out what my y-coordinate is. Taking 0 squared is 0, opposite of 0 is 0, plus 4, 4. So my vertex, I had an x-coordinate of 0, y-coordinate of 4, and I'm going to map it on the graph and put a V by that point. We realize our A coefficient, if you haven't already, negative, so I'm paying attention to being down. Third step, axis of symmetry. Goes through the x-coordinate. I'm going to make sure my vertical line, ironically, it's that axis, but we should still kind of put a dash line through it so we recognize it. I got to figure out another point on this line. 0 is an x-coordinate that's already been taken. So we got to pick another x-coordinate. I'm going to pick 1 just because it's easier for myself. So if I plug in 1, I get 3. So I get a 1, 3 is what I'm mapping. That point 1, 3. I got to map it to the other side of that axis of symmetry. So here's what I need you to do. You're going to have 2 problems I want you to do tonight. I need you to do 21 and 23 to see if you understand how to graph a parabola in standard form. This is on page 253. You're only supposed to do problems 21 and 23. If you want to see what we're coming up against, we'll be able to do these other 4 come tomorrow.